Okay, here is number 23. To solve this inequality in graph, so I'm going to subtract 12 from both sides. I get 2x is greater than or equal to a negative 8. I'm going to divide by 2. Since I'm still dividing by a positive, I don't do anything with the sign. X is greater than or equal to a negative 4. So at negative 4, since it's greater than or equal to, I put a solid dot, and I'm going to shade going this way. Going that way. Okay, 25. I'm going to distribute this negative 2 first. I get negative 2x minus, negative 2 times negative 3 is a positive 6, which is greater than 5x plus 27. I'm going to subtract 5x here. Subtract 5x. I get a negative 7x plus 6 greater than 27. Subtract 6. Negative 7x greater than 21. Greater than 21. I'm going to divide by a negative. Once I divide by a negative, I know I have to flip this sign. So the sign gets flipped. 21 divided by negative 7 is a negative 3. So I go to negative 3. Since it's a less than sign, it's an open dot, open circle. It's pointing that way to the left. X is less than this way, so I shade this way. Big arrow continues going that way. All right, let's do this one. I'm going to subtract 6x from both sides. I get a negative 3x plus 7 less than or equal to 43. I'm going to subtract 7 on both sides to undo that addition. Negative 3x less than or equal to positive 36. I'm going to divide by a negative 3. Once I divide by a negative, I know I have to flip this sign. So I get x. 36 divided by negative 3 is a negative 12. That's my answer. I go to negative 12, and I put a solid dot. And I shade to the right. Okay, that was graphing. Now it says solve the inequalities, verify that the given numbers are elements of the solution set. So I'm going to solve this. I'm going to add 14 to both sides. Plus 14, 3x less than 21. Divide by 3, x is less than 7. So, is x is 10 less than 7? No, it's not. Or you could put 10 into here. 3 times 10 is 30 minus 14. 30 minus 14 is 16. Is 16 less than 7? No. So this is not part of the solution set. 31. I'm going to add 10 to both sides. I get 6x is greater than 48. I divide by 6. I get x is greater than 8. So is 8 part of the solution set? Well, is 8 greater than 8? No. If it said greater than or equal to, it would be good, but this is just a greater than sign, so no. All right. So, a couple of word problems now. Let's do 33 here. Gretzky sets a new record for the greatest number of hockey goals in one season with 92 goals. Suppose a hockey player has 59 so far in the season. He wants to continue to make goals this season in order to match or break his Gretzky's record. Which inequality represents the amount of goals a hockey player needs to match or break? So, if Gretzky has 92, this guy wants to get 92 or better, right? So greater than 92. So we have to have whatever's over here greater than 92 or equal to. I like this one. That's greater than or equal to. No, that's less than. This is just greater than. That's not right. And this is a less than. So this is it. He already has 59. Well, he's going to be 59 plus the amount of goals is going to be greater than or equal to 92. Don't even have to figure anything out. If X represents the number of hockey goals it takes to reach the record, what is the inequality that represents the amount of goals it takes for the hockey player to reach or exceed? So now we have to solve up here. I'm going to do that right here. I'm going to write this equation. 59 plus X greater than or equal to 92. I'm going to subtract 59 from both sides. I get X is greater than or equal to 33. So X is greater than or equal to 33, right there. Okay. Oh, that was 34. That was an even, but we did that anyway. Let's do 35. So Juan has a $30 gift card to the creamery. Each blaster costs $3.59 with tax. At most, how many blasters can he buy? He's got 30. Each one costs this. Write an inequality. So he has $30. I like to write that on the right side. Can he spend more or less than 30? He has to spend less than or equal to 30, right? So each blaster costs $3.59 times X. So X equals number of blasters. Number of blasters times 359 has to be less than or equal to $30. Okay, we would divide by $3.59. $3.59. I'm going to get X is less than, let me come over here. I'm going to do this on the calculator. So I get 30 divided by 3.59, 8.35, 8.36, let's call it. Right? So what does this mean? Can he buy 9? Can he buy 8? He can buy 8. Right? So this means 8 blasters. He can buy at most 8 blasters with this $30. Write your answer in both interval and set. So interval, well, he could buy 0 all the way up to 8. Correct? Set notation, the set of all X such that X is less than or equal to 8. Or if we want to do the compound inequality, we could say set of all X such that we go from 0 less than or equal to X less than or equal to 8. This is a compound equality. This is a regular one. We can just do this piece right here for the test. All right, last page here. 36 is even. I'm going to do 37. Average of David's 4 most recent Math 1 tests must be at least 90. So at least 90 means that these grades over here have to be greater than or equal to 90, right? If he receives a 87 plus 90 plus 94 on his last 3 tests, what does he need on his next test to keep the A? So plus X, and I'm going to divide by 4. So I'm going to add all these up. 87 plus 90 plus 94 equals 271. I'm going to write this over here. So 271 plus X over 4 greater than or equal to 90. I'm going to multiply by 4 on both sides to cancel this. 271 plus X greater than or equal to 90 times 4, 360. I'm going to subtract 271 from both sides. I get X is greater than or equal to, so 360 minus 271 equals 89. X is greater than or equal to 89. He's got to get it 89. He needs to get at least a 89% on the next test to keep his 90% average. Sorry, a little messy. 90%. Okay, answer in interval notation. Well, he's got to be greater than or equal to 89. So he can score an 89, or all the way up to max he get on a test is 100. Set notation, let's write this as a compound inequality. Set of all x such that x is trapped in the middle between 89 and 100, and it's going to be like this. They're always going to be less than or equal to signs. So this means x is greater than 89, greater than or equal to 89, and x is less than or equal to 100. That's what it means. Okay, or if you just want to write the simple one, set of all x such that x is greater than or equal to 89. We'll accept that on the test. Okay, that's all the odds.